Hello. In this example, we have f of x equal 8x minus 9, and g of x is equal to 2x minus 1. Excuse me, the square root of 2x minus 1. Letter C says f times g of x. What this means is f of x times g of x. And this means 8x minus 9 times the square root of 2x minus 1. Now, if this was a binomial, I would recommend that you FOIL this. However, 8x minus 9 times the square root of 2x minus 1 isn't going to look any better if we distribute this to both of those terms. Therefore, this is really as far as you need to go here. So, I would say that f times g of x is equal to 8x minus 9 times the square root of 2x minus 1. Let's look at letter D, f divided by g of x. What this means is f of x divided by g of x. Well, f of x is 8x minus 9, and g of x is the square root of 2x minus 1. And I would say leave this here, except for one thing. There is a radical in the denominator. Because there's a radical in the denominator, I need to get rid of it. To do that, ask yourself, how do you get rid of a square root? If you said square, you're correct. Now, I can't just square the top and bottom. It doesn't work that way. What you have to do is ask, what do you mean whenever you square something? You mean multiply it by itself. So what I'm going to do is I'm going to multiply the denominator by itself, which is, in this case, the square root of 2x minus 1. But if I do that to the denominator, I have to also do that to the numerator as well, because whatever you do to one side, you do to the other. Then you multiply. Notice that the numerator is effectively going to be f times g of x. So that is 8x minus 9 times the square root of 2x minus 1. All over, now square root of 2x minus 1 times square root of 2x minus 1. We did that to cancel the radical, and it does that. What you're left with is 2x minus 1. And this is f divided by g of x. Now, it doesn't specifically ask for it. However, I do need to talk about the domains. However, I've already gone on a little bit longer on this video, so I'm going to come back in another video and talk about the domains for all of these function operations.